Hello students, welcome to Eshwari channel. Students, in this video we are going to learn 10 tricks to find acidic strength in aromatic acids. Students, I have already made one video to find out the strength of the acid. This is the second video. If you have not watched first one, you can watch that video. So now trick number 1. So we are going to compare the strength of benzoic acid. This is benzoic acid with another acid. So to this benzoic acid, if electron withdrawing group is attached at ortho, meta or para position, then this acid will be more acidic when compared to benzoic acid. Consider one more acid, that is to the benzoic acid, if electron donating group is attached at meta position or para position, then benzoic acid will be more acidic when compared to this acid. So this is trick number 1. Trick number 2. To find out which is more acidic, we have to consider 3 effects. One is called as mesomeric effect or resonance effect. Second is hyperconjugation. Third is inductive effect. So here we have written electron withdrawing group and electron donating group. So electron withdrawing group, electron donating group. So this groups, which effect it will show, whether it shows M effect, HC or I, let us find out. Mesomeric effect is of two types, plus M effect, minus M effect. So plus M effect is shown by electron donating group. Minus M is shown by electron withdrawing groups. Same way, inductive effect. There are two types, plus I, minus I effect. Electron donating group shows plus I effect. Electron withdrawing groups shows minus I effect. So here you can see electron withdrawing group. Electron withdrawing group shows minus M effect. Electron withdrawing group shows minus I effect. And then plus M is shown by electron donating group. So electron donating groups will show plus M effect and then plus I effect and even hyperconjugation. So all these effects are shown by these groups. So this is trick number 2. Coming to trick number 3. So plus M and minus M effect we studied already. So if you don't know whether the group shows plus M effect or minus M effect, I'll teach you a trick. Plus M effect, minus M effect. Suppose in the group, if first atom has lone pair of electrons, then it shows plus M effect. Suppose first and second atom in a group has double bond or triple bond, then it shows minus M effect. So we'll take example for plus M effect is OH. So students, you know that on oxygen, two lone pair of electrons will be present. So this is the first atom in the group. it has lone pair of electron. Therefore, OH shows plus M effect. And here for minus M effect, example is NO2. Example NO2. So here you can see between first atom and second atom there is double bond. Therefore, this shows minus M effect. So some more examples we will take. Example NH2, OCH3, CHO, C triple bond N. So first one, whether it shows plus M effect or minus M effect. On nitrogen, one lone pair of electron will be there. So this shows plus M effect. On oxygen, two lone pair of electrons will be present, plus M effect. And here between first and second atom there is double bond. So it shows minus M effect. So students, this is for you to try. So tell me in the comment section whether it shows plus M effect or minus M effect. What is your answer? So you can write in the comment section. So next, going to trick number 4. So here we will take benzoic acid and you know that these two positions are called as ortho position. These two are called as meta position and this is called as para position. So if at the ortho position, if electron donating group is present or electron withdrawing group is present, so it can be any group. At the ortho position, if it is present, then this acid will be more acidic. So this is trick number 4. So let me take one example so that you will understand it clearly. So students, compare these two acids, which is more acidic in nature. So see here at the ortho position there is here two lone pair of electron. So if lone pair of electron is present, then it will be showing plus M effect. And here there is a double bond with between nitrogen and oxygen. Therefore, this will be showing minus M effect. So plus M effect meaning is electron donating group. So here it is electron donating group and here it is electron withdrawing group. So here the trick is it can be electron donating group or electron withdrawing group. So but it will be more as acidic when compared to other acid. So now this is more acidic when compared to benzoic acid. We are comparing these two acids. So now this acid is more acidic when compared to benzoic acid. Even here this will be more acidic when compared to benzoic acid. So the trick is let any group be present at the ortho position, that will be more stable. This is called as ortho effect. So we will study in detail ortho effect. So now trick number 5. So we studied about ortho effect. That is, whichever group is present at the ortho position, the acid becomes more acidic in nature. So ortho effect is shown by SIR. That is steric hindrance of resonance, and then electronic effect. Electronic effect. For example, take benzoic acid and take acid to which a group is attached at the ortho position. So this group can be electron donating group or it can be electron withdrawing group. So now what happens is, if it is benzoic acid, here the lone pair of electron which is present will shift here and this will shift here. So now this will become CO minus, double bond O, hydrogen, and there will be positive sign on oxygen. So students, you know that oxygen is highly electronegative atom. So if positive sign is present on it, it becomes highly unstable. It requires electron. So now behind oxygen there is a benzene ring. So here electron supply will be done by this benzene ring. So that is why oxygen will not easily take this electron and will release this hydrogen. Whereas here you check, there is lone pair of electron and here since group is present at the ortho position, so here this group goes out of plane. So this will go out of plane. CO minus, double bond O, positive sign, hydrogen, and here there is a group. So now this group has gone out of plane. Now again oxygen has plus sign. So it requires electron. So now there is no back supply of electron from benzene ring because it is out of plane. Therefore the only option for oxygen is to take this electron so that this will be released as H plus ion easily. Therefore this acid becomes more acidic because of the group present at the ortho position. This goes out of plane, because of which oxygen will take electron from here and hydrogen H plus ion will be given out easily. So this is ortho effect and this is called as steric inhibition of resonance. Next is trick number 6. Suppose OH group is present at the ortho position, we will see what happens. So here, if you remove this as H plus ion, so here remaining will be O, there will be a partial double bond character and negative sign on oxygen. So now this O and hydrogen, so there will be a hydrogen bonding between this oxygen and hydrogen, because of which this group becomes stable. So this is hydrogen bonding. So this acid becomes stable and therefore it is more acidic whenever OH group is present at the ortho position. This is electronic, one of the electronic effect. So we studied what is SIR, that is steric inhibition of resonance. When a group is present at the ortho position, it will make the group to go out of plane. Electronic effect is hydrogen bonding. So when a OH group is present at the ortho position, so hydrogen bonding will be formed between oxygen and hydrogen, which will make this group more acidic. Next is trick number 7. So trick number 7 is, so I said you that to find acidic character, 3 effects we have to check. One is mesomeric effect, second is hyperconjugation, and third is inductive effect. When all these 3 effects are present, to which we have to give preference? We have to give preference to mesomeric effect first, and then hyperconjugation, and then inductive effect. So we will take one example and understand this. So this is one structure 2, and this is structure 3. So we have to find the acidic strength of this acids. So students, here what is the effect shown by OH group? So here lone pair of electrons are present, therefore it will show plus M effect. It is showing plus M effect. And then carbon and oxygen, which is more electronegative? Oxygen is more electronegative. If it is more electronegative, it will be showing minus I effect. And it is OH group is present at the ortho position, so it will show ortho effect as well. Ortho effect. So here it is showing three effects: plus M, minus I, and ortho effect. And here we will see OH group, here it will show minus I effect, and there is no plus M or minus M. You know that if it is at the meta position, M effect will not be shown. So only minus I effect here. And at the para position, so this group shows plus M effect and then minus I effect. So when two effects are there, for which you have to give more preference to the mesomeric effect. So give more preference for the mesomeric effect. So coming to the stability order, which is more stable. So here ortho effect, if it is there, it will be more stable. Whenever group is present at the ortho position, so that will be more acidic in nature. So one is more acidic when compared to. In this we have to see which is more acidic in nature. So minus I group means electron withdrawing group. So electron withdrawing group, and plus M means electron donating group. This is electron donating and this is electron withdrawing group. So electron withdrawing group will be more acidic when compared to electron donating group. So this is 3. So this is the order. Next, trick number 8. So trick number 8 is, if halogens are present, halogens means it is chloro, bromo, iodo, fluoro. So we have to check only minus I effect. So if halogens are there, check only their minus I effect. For example, so this is benzoic acid. So find the acidic strength here. So this is structure 1, this is 2, this is 3, and this is 4. So if halogens are there, we have to check only the minus I effect. So here it is showing minus I effect. So here also it will show minus I effect. Here also minus I effect and minus I. Okay, here there is no group. So here minus I effect means electron withdrawing effect. So all these three will be more acidic when compared to benzoic acid. So benzoic acid will be last. So here this is last. So now in this three we will compare. So here chloro group is at the ortho position. So students, you know that inductive effect depends on distance. So closer the distance, the effect will be more. So here electron withdrawing effect will be more here when compared to this two. So here this is more acidic, 1 and then 2 and then 3. Last will be 4th one. So this is trick number 8. Next we will go for trick number 9. So trick number 9 is, this is the group. If the size of the group is bigger, then acidic nature of the acid also will increase. For example, fluoro group, fluorine. So in this we have to find the acidic nature. So students, you know that size, if you see, iodine will be bigger in size. Iodo group will be bigger in size when compared to fluoro. So here iodo will be bigger, then bromo, then chloro, then fluoro. So whichever if the size of the group is bigger, the acidic character will be more. So why? Because of steric hindrance. So here this will be more acidic, this is second, this is third, and this will be fourth. So last trick number 10. So if SIR, steric inhibition of resonance, is present in all the structures, then you have to check only M effect, hyperconjugation, and then I effect. That is, if a group is present, so for example you take so we are taking these two acids. So in these two acids, you can see at the ortho position NO2 group is present, and at the ortho position OCOCH3 is present. So both are showing ortho effect. So when both are showing ortho effect, next what we have to do is consider these three effects. So here NO2, N has double bond with oxygen. Therefore, this will be showing minus M effect. Between carbon and nitrogen, nitrogen is more electronegative. Therefore, it will show minus I effect. And here, oxygen has lone pair of electron. Therefore, it will show plus M effect. And oxygen is more electronegative when compared to that of carbon. Therefore, it will be showing minus I effect. When two different effects are there, so M is electron donating group, minus I is electron withdrawing group, then you have to give preference for M effect. So here we are giving preference for M effect here. So which is more acidic here when you compare these two acid? Electron withdrawing group, if it is present, that will be more acidic in nature. So here minus M is electron withdrawing group. So this acid will be more acidic when compared to this, where this is electron donating group is present. So this is how we find the strength of the acid. Students, I will meet you in the next video.